Okay, and I think people have filtered in now. So welcome back again. Welcome to webinar 4 in the Discovery Space Fall Webinar Series. So I'm your host, Michael Gregory from EPS, the European Physical Society, and I'm joined by Maria Luisa from NUCLIO, who's going to be the main host of this one. And for the next several ones, the next 4 or like 3 after this one, we'll be co-hosting them together. And as announced in the emails, but I'll explain it with voice too, because that can be more engaging, or maybe it'll stick more. The next couple of sessions, we're going deeper into Discovery Space. So far with the fall series, the first 3 sessions were fairly introductory. We recommended mainly for people who were new to Discovery Space, because it might be a little bit repetitive for people who had been either at a summer school our Spring into Discovery Space webinar series. But now that it's in October, we've got 4 ones where we're going deeper and deeper into different aspects of Discovery Space. So today, Maria Luisa is going to be going I blanked on the word we're using for today. Like understanding how but we used a different word than understanding, but understanding how the learning scenario.
How DSpace learning journeys work.
Oh, that's right. I mean, I just got to scroll down to the schedule I have open in another window as well. Yeah. So we said inside the scenario.
Inside,
Yeah.
yes.
Okay. Uh, and then the next ones are adapting the scenario, creating the scenario, and beyond the scenario. So the things we'll focus on that next week will be focused on adapting and modifying existing scenarios, either adapting to the target language of your students if they're not speaking English, Portuguese, or Greek, and you're relying on machine translation, or adapting to your school program, or whatever constraint is more appropriate for your classroom. Then in 2 weeks, we'll be going into how to create your own scenario. Unfortunately, like you'll have seen so far, if you're familiar with Discovery Space, it'll be more in depth than you can do within a webinar itself, but hopefully we'll be able to get you on your way so that you're able to understand the process and what's needed for the creation. And then the final webinar will be looking beyond the scenario, which is how you can become an ambassador for Discovery Space and share it with colleagues in your local area, in your school, and go beyond just using it in your own classroom. So that's the kind of where we are going, and it's great to see a number of familiar names, familiar faces. And it looks like you guys understood the September ones probably weren't that interesting if you were with us in the spring, but now you're back as we're going deeper. So it's great to see a number of you back with us. So welcome back.
Thank you, Michael. Yes, I think we are trying now to move a step further, and it would be great if you could also interact while I'm presenting. I'm going to show you some slides just to have a wrap up of the real goal of DSpace, what it is about. It's a very quick summary of why we have DSpace and the platform and so on, just because maybe not everyone is already familiar with the DSpace, but just so that our minds are set on what we want from the scenarios. And then I'll try to explain a little bit more what do we have to think about when we create a scenario. I'm not going to show you a perfect scenario, the other way around. I'm going to show you a scenario that was changed from the beginning because of the platform, so it wasn't exactly what we expected. And now it has had many implementations, and now it's going to be changed again after the experience. So I'm going to try to share my uh, my presentation, but our experience just a few minutes ago wasn't very good. Let me see. Um, how does it look like?
It's still zoomed in quite close onto the logo.
I don't know what I can do. I'm in the, like this. Better? Didn't do anything? Didn't change anything?
Oh, that's really weird. I've never seen this happen before. That will need to depend on participants interacting already to tell us what they see. But I realized I can actually scroll around what I see on your screen and I can zoom in and out. So I have control over how much of your screen I'm seeing on my screen.
Oh.
I've never seen that behavior in Zoom before. And I can anyone else let us know? Can you change the zoom level you're seeing of Maria Luisa's screen? Or is it just something I have as host? Because either as host or as a participant, I've never seen Zoom behave like this before. I don't know if it's a new
I
setting.
can zoom also.
It's a
Okay, so
take-out part.
okay, so you can zoom. So if it's zoomed in too much, zoom out, and for some reason it's up to you to zoom in and out as you need to.
And like this, the same thing, or did it change?
Whatever you're doing didn't change how I see it at all. I'm still totally in control of how much I zoom in or out and where I pan across your slides.
Okay, and did you need to zoom again?
I needed to zoom out as much as possible to get the whole slide going.
Yeah, it seems like it's new for everyone. I'm very sorry that it happens, but nevertheless, it's a very small presentation. It's just so that our mind goes a little bit back to what Discovery Space is all about. So the first thing I wanted to remind you is that we want with DSpace to go further than just the surface learning. When you have a surface learning, that's an initial phase where students get the new concepts, they develop some skills, but it's just the fundamental things that they acquire before really going into thinking in a more complex way. And what DSpace would like to achieve is what is called deeper learning. So when we are talking about deeper learning, it involves moving beyond the basic understanding. It's going to a more comprehensive understanding of concepts. This means that they develop not only the knowledge in a meaningful way, but they also acquire more competencies and more skills, and they are better equipped to explore the subjects afterwards in a deeper level. So this is what DSpace is about, is trying to get from a surface learning to a deeper learning. And it has been studied that there are several pedagogical approaches that promote a deeper learning, especially deeper learning, not only in knowledge, but also competencies. So you can find here a few of them, or I think that most teachers have heard about them and dealt with them and even used some of them. The project-based learning, inquiry-based learning, problem-based learning, challenge-based learning, case-based learning. So these are typical instructional methods that you can use to try to achieve a deeper learning with the students. What do they all have in common? They try to engage the learning so that the students are the center in the whole activity of the learning activity, and they are active. So these three wheels go around with all of these pedagogical approaches. So the idea is to have the students in the center. What happens is that it is very difficult to be able to attend every student way of thinking, what they already know, their level, their initial level, how they work, how they develop, and so on. So we have the Discovery Space project that has developed learning scenarios, and it was an option to follow inquiry-based learning. It has an online platform where the scenarios are created and are used with implemented with the students, and it fosters the use of online laboratories. It can be either real remote labs or just online labs that are are more like simulations than real labs, but can be very useful for the students to have a good experience, especially when schools don't have them. And it also has an exploratory learning environment, it's a nice word, with an AI-driven learning companion. I'm not going to talk now about this. This has been already covered in another webinar, one of the first ones. But I'll try to show you how this was applied to the scenario that I'm presenting. So today it's more like in a practical level of how to create and what you have to think about when you're thinking in creating a scenario with the DSpace platform. I'm just going to remind you that the inquiry-based framework, it has different phases. We opted for a five-phase framework, although there are different frameworks that can use more or less phases. It's not that important. The important thing is that we want to engage the students with starting by presenting them some phenomenon, some topic that they will start talking about, discussing. They will try to come up with everything they know about that subject until they are asked to make a hypothesis to explain the phenomenon. And then they will go to the experimentation phase, where they should have a laboratory or an experience. It can be online, it can be physical, but they should be able to plan an experiment that will test the hypothesis, gather data, then they go to the data analysis, make something out of what they got from the experiment. Maybe they will have to go back and reformulate the hypothesis or reformulate the experiment. It happens, and it's not bad that it happens, it's good. It shows how science is made. It's exactly what happens in real life for scientists. And then, of course, there is the reflection where they can compare with other people's results. They can see, they can go further into the subject and explore a little bit more. So all the scenarios that are developed in the platform, the DSpace platform, are going to follow these phases because it was a decision to have it as an inquiry-based framework for the scenarios. It's important to understand that it was chosen and it was thought as a way to relate to problem-solving processes, which is one of the things that we have we want that DSpace explores is exactly problem-solving processes. The structure of the scenario or the workflow of the scenario is obviously going from the engagement towards the reflection. But we do have a challenge. Not everyone can go directly from here to here in a way that they really understand what they are doing. So what happens many times is that some students, they might even understand a little bit of the beginning, but they get lost at the hypothesis or at the experiment phase or something like that. What DSpace would like to do is, during this phase, it will try to give support to every student that really didn't understand what was happening, so that they could go to that deeper level understanding before they go to the hypothesis. And this will happen in each phase. Some students won't need that much help, and they can follow another path that gives them the opportunity to explore other things, but others will be able to really understand the whole goal of the activity, not just following step after step just because everybody is following. So the challenge is to design an activity with questions and with problems that really engage them, and at the same time it differentiates their understanding, because not all students will understand in the same way. So we wish that we can address the specific misconception that each student has, and we can give them feedback. We want to support and guide each one along their own path. And we wish also to address the student specific interests and provide materials so that the student is encouraged to really give everything to the learning process. And we also wish to follow in real time each student's progress. So in a very summarized way, this is what DSpace is all about. And today I'm going to take you on this journey. It's embarking on Earth's annual journey, which is one of the scenarios that is available. And I'll try to explain the best I can the different challenges that come up when we start creating a scenario. So I'm going to end the show. Probably I'm not sharing anything, right?
Yeah, your share is done now.
Okay, my share is done. So I'm going to share my computer screen, which is always challenging, so that I don't show what I don't need to show. Let me just
Always nerve-wracking, like thinking, do I have that open?
So entire screen, and the first thing I have to take. Do you see yourselves or do you see my things?
Yeah.
I can see your stuff.
Great, thank you. Thank you. So this is going to be here. So first of all, I don't know if everyone knows the Discovery Space. Maybe, I don't know if you have already, Michael, put the link of the Discovery Space down
I should put
there.
that again. I sent it out in the email, but I have all these
Yeah,
links
it's
ready
always
to
good.
share as they come up. Yeah.
Yes. So over here you have the full webinar series. But what I wanted to show you, because this is always a good way to get to the platform, is Resources Trust AI Lab Platform. And here, click the button to access the platform. And like this, I can also show you that you do have here the tutorial in English, in Greek, if you need some support. So I have this opened. I already had this opened before, but now I'm at the dashboard, which is not the best way to start with the platform. Over here, authoring tool has a list of the scenarios. I will see all public scenarios, but I will also see my own scenarios. The one I'm going to explore with you is embarking on Earth's annual journey scenario. Okay, so right over here, I know this is not very nice. I thought I would put some comments so that I could explain what was in my mind when we created this scenario. So the idea was a scenario about the seasons. For the Portuguese curriculum, that would be 12, 14 year olds. And the first thing is to think about what are the learning objectives. So in this case, what we really want as learning objectives, we want them to understand the cause of the seasons, and we want to investigate the relationship between light angle and heating. So these are the two main objectives of our scenario. But also we want them to apply the inquiry skills, to connect models to real-world phenomena, to develop scientific reasoning. That's why we are using DSpace and using the inquiry learning approach. When we have a scenario, I'm going to close this, you should always see over here the 5 phases of the inquiry-based learning framework: engagement, hypothesis, experiment, data analysis, and reflection. In this case, the platform only allows you to have these once and in this order. This is just to explain why our first scenario didn't work, because I think I have it over here. Yes. So the first time I thought about the scenario, I had engagement, hypothesis, experiment, data analysis, reflection, and then I would continue with the new engagement, hypothesis, experiment, data analysis, and reflection. So I was trying to have it going through the different phases whenever it was necessary. And in this case, it was like a second repetition. I had to cut it so that it would be only these 5 phases. Now let's think what could be a typical inquiry learning activity. So, oops, I didn't want to have this big, sorry. For the engagement, the teachers could discuss with the students what they already know about the seasons. They could show a video, some pictures, whatever you can think about that has to do with seasons, and discuss with them what they think are the different seasons. It will depend, of course, where you are, and the teacher can explore their ideas, and they should never say if they are accurate or wrong, because what happens is that many misconceptions come right away from this discussion. I'm talking especially about the seasons, because the seasons is something that it's a topic that teachers do have difficulties in having the students understand it in a deeper way. In a superficial way, everything is okay. They can answer those classic questions. It has to do with this, this, and that, and it occurs at this time of the year, and it's like this in the north and like this in the south. But usually it's a question of memorizing and not a question of really understanding. So this is a topic that deserves a little bit more attention, because it needs something extra so that they can get a deeper learning about the subject. So in a typical inquiry learning activity, we would engage the students and know what they already know about. We would guide them to formulate a hypothesis that has to do with the tilt of the Earth's axis. Why am I saying that it has to do with the tilt of the Earth's axis? Because if I'm doing something online and I know the laboratory, the online lab that I'm going to use, and it's about the tilt, I cannot have here a very open hypothesis action with them, because otherwise I could have many other hypotheses, and I could have the students try to figure out how to do an experiment to prove or disprove their hypothesis. But since we are doing something online and there is already a chosen online lab, we are guiding them to a hypothesis that has to do with the tilt of the Earth's axis. So the hypothesis is done. We lead them to, we introduce them to a simulation or a real lab, what we have in our minds. In this case, for the seasons, we thought that it would be a online simulation. And the students, first, they have to understand the lab. They have to understand what are the variables, the independent variables and the dependent variables. How are they going to plan the experiment? So at this phase, it's not very specific of this scenario. It's something that all inquiry-based activities should be very focused on making sure that the students know what they are changing, what variables they are changing, what makes sense, when should they change a variable, and how they should plan the experiment. Typically, we have, especially when they are young, they will try to vary everything at the same time. And of course, they will come to the conclusion that if they vary everything at the same time, they won't get any result that they can understand the contribution of each variable. So the part of the experiment should focus on the lab, so that the students do understand the lab and how to plan an experiment. And of course, how to collect the data. In the case of the online lab that we had chosen, it will be how the light angle affects the surface that it's hitting. And then we would go to a data analysis. They would have the data they obtained, and they will draw conclusions about the relationship between the Earth's tilt, the sunlight angle, and the temperature. And from there, they will try to explain why the seasons occur. And of course, they should see their colleagues' results. They should even go further to understand, for instance, why the seasons, how do the seasons and the different climates in the different regions differ. So that's going further into the subject of the seasons, although the goal over here is more to understand the cause of the seasons. But of course, in different regions, we do have different manifestations of the seasons, so that it's also something that they can go further. So this is a typical inquiry learning activity. What happens is that somewhere over here, not all students will be following what is happening during the activity. We have to think about ways of understanding what is in their mind and how to guide them to understand better what is happening. So for instance, in the engagement, you can show a video, images, tell a story or show a painting, so that they start talking about the seasons and ask what causes the seasons. For the platform, I'm going to show you the whole view of the scenario. So you saw that we have here the 5 phases, but we will have over here something about the first phase, the hypothesis, the second phase, then the experiment, data analysis, and then the reflection. Okay? So instead of just asking what causes the seasons on Earth, we are going to try to find out if they already have some misconceptions, if they already know something about what causes the seasons. To address typical misconceptions, one thing I did at the time, and this is not the results I had, I explored in other places, but this is just an example. For ChatGPT, if I just ask them, it will automatically come with a few of the misconceptions that are usual about what causes the seasons. I did more in-depth search, but just to give you an idea, seasons are caused by Earth being closer or further from the sun. The sun's rays are stronger in summer because the sun is higher in the sky. The seasons are the same everywhere on Earth. The tilt of Earth changes during the year. So there is quite some ideas that usually pop up. And if anyone over here is a physics teacher, you know that there are always some typical misconceptions. And this applies to any other topic that you want to create your scenario. So you should think about where do students usually have more difficulty before you start doing the scenario. So the way the platform works, when you have an activity or a question, you should give at least 2, but preferably 3 possible answers. And each answer should show a level of understanding. So this is our real challenge when we are creating our scenarios. 3 levels of answers, probably one that is a student that already knows something and understands something about the subject we're focusing on. Someone that, a student that has an idea, but is not really sure, and then someone that is completely off what this is all about. For instance, in this case, the 3 answers that I gave them to choose was the tilt of the Earth's axis, the distance between the Earth and the Sun, or the Earth's rotation has to do with the day and night on Earth. The first one is exactly what we want them to know, that it does have to do with the tilt. The second one is one of the biggest misconception that students and grown-ups have. And the other one is something that hasn't even read the question or never thought about why we have the seasons. So now that we have chosen the 3 level of the answers, how are we going to go further? The first one doesn't need anything else at this time. The first one can go immediately to the next step, but the other 2 will need help. So, for instance, I can think about why do they, we know that they think that it's the distance because they think the sun is closer, so we are warmer. How can we have them think that that is not the cause? There are different ways. The idea is not to give the answer, the exact answer. That's the last thing we want to do, but we will eventually need to do if they don't understand. But maybe we can have an extra step for these students so that they can come to the conclusion that it is not the right option. In this case, this is what we thought could make them think a little bit. In fact, the distance between the Earth and the Sun changes throughout the year, so they are right. That's something that they already know. But the cause for the seasons, we show them 2 images one in Sydney and one in Lithuania, in Vilnius, Lithuania. And what happens, it's Christmas on both. And one is summer and the other one is winter. What are we expecting them to think? Do you still think that it is the change of the distance between the Earth and the Sun that causes seasons? Because if it were a question of distance, then we should have the same season on both hemispheres. So the idea is to give them something to think about before they go to the next step. They might have understood, or maybe they still need a little push. And that little push can be just making sure that they understand that in December it's winter in the northern hemisphere and it's summer in the southern hemisphere. So the Earth will be at the same distance, the southern hemisphere and the northern hemisphere. So it doesn't make sense, they think, thinking that it is the distance that is the cause. So this was a way to try to have them solve the problem that, okay, you're saying that it's the distance, but if it were the distance, we would have the same season in the northern and in the southern hemisphere. Okay? So I'm going back to the phase and back to the scenario. And I'll just show here the engagement. So those that already knew it was the tilt will go immediately to the next step, the next phase, the hypothesis, while the other ones will go through different questions. It could be, it could involve experiments, it could involve a lab, it could involve many things, but they need this extra help to get here to the hypothesis, to the beginning of the hypothesis that is telling them that, okay, you have to understand that it is from the options we gave you, it's the tilt of the Earth's axis that we are going to explore how it can cause the seasons. So far, so good. Any questions? No? Everything okay?
And just on the topic of questions, I was typing a reply in the chat, but it's probably better if I just speak to explain it. So there's someone having a hard time seeing the scripts when logged into the account. So I started writing a suggestion that there's a difference between teacher and student accounts. So if you have multiple accounts, if you're in the student account, you'll only have the student view where you see the scenarios that have been selected for that student group. Likely it'll be one or two. It depends on how the teacher, if it was us who created student accounts for you, like in the Spring into Discovery space, I think we had 2 or 3 available in the student view. Whereas if you're logged into the teacher view, you should have a view of all the public scenarios, plus any ones that you've either created or created copies of. But by default, you won't have created copies or created any of your own. But the public ones, because different language versions count as different ones, there's approximately 20 to 30 of those right now. So if you could see whether you're in the student account or not, and we can hopefully help troubleshoot more how you can see things.
I'm showing how the student would see. So I'm in the teacher account, but the teacher can see the student view. So this would be the student view, if this helps. Who is not able to see this part of the authoring. The student view is something like this. The teacher view is something like this. Okay? So we have the different phases, and at each step, not at each step, but during the phases, you should always consider if the student is really understanding what is happening, and give and provide different paths so that they can go to the next phase. In this case, all of them will end up over here, knowing that it is the tilt of the Earth's axis. And with one question, the question is, sorry, it's over here, the content. We shall now investigate how the tilt of the Earth's axis might cause the seasons. What do you think? And again, we have three possible answers. The higher performers, if we want the ones that already know something about it, will go directly over here and will investigate that the tilt of the Earth's axis causes different parts of the Earth to receive sunlight at different angles throughout the year, leading to the changing seasons, which is the hypothesis that we want them to study. So this will be the student that is already focused on knowing that it is the tilt that makes the different parts of the Earth to receive the sunlight at different angles. But I think I can do this. There are other ways that students can think that the tilt of the Earth can be responsible for the seasons, and they are interesting ones. One is that it makes one hemisphere closer to the sun than the other, and it is true. If we think about the tilt of the Earth, there will be a hemisphere that is closer to the sun than the other. What we explain to them, because this one, it's not something that, well, it is something that we can make them do some calculations to understand that although it is true that the tilted hemisphere that is closer is closer to the sun than the other, the amount is very, very little compared to the distance that the Earth is to the sun. So it won't really contribute to the being a warmer hemisphere, the one that is tilted towards the sun. So over here, we aren't asking them to do the calculations, but we could ask them to do the calculations so that they see that it's too low to be a contributing factor, okay? And I'm saying this, but we ask them to calculate, and it's going to be a really, really small contribution in the distance. So that shouldn't be the basic reason for the seasons. And the other one has to do with the tilt of the axis that changes. And it is true that it changes, but it changes in a time scale that has nothing to do with the seasons. So these are all interesting hypotheses that they end up putting. So their answers. Sorry, I want it over here. So these two are quite interesting, but they don't really tell us why the tilt causes the seasons. So if I go back to the scenario, now they know that the hypothesis is the same, that for all level of students, they're going to investigate this hypothesis. Okay. So back to the scenario, experiment. Now for the experiment, what is important is that they know the lab that they're going to use. It's important to know the variables that the lab allows you to change. It's important for them to understand the difference between independent and dependent variables. And then after knowing this, they should be able to design their experiment. This means that they should be able to plan how they are going to use the lab, which variables they are going to keep constant, and which ones they're going to change at different steps. So this is all about designing their experiment. In this case, I think this is something that this scenario needs a little bit more of work, because it's very open. This means that the teacher has to go and look at what the students are doing, and the idea was that we could have everything inside the scenario. We didn't have to have the teacher going around, just because this is one of the scenarios that we wanted to implement last year, and we did with a high number of students. So as you see, the rest of the structure is quite simple, in the sense that we ask them questions about the analysis, the data analysis. And for instance, we have all of them going through the same 3 questions. And depending on what they answer in all of them, we consider that they really understood or that they really didn't understood completely. So you can also have a set of questions that will have a punctuation, and they will score if they get it right, medium, or low. And in the end, you can add up and think that, okay, they got all of them right. They can go to the reflection phase. If they only got a few right and a few wrong, they need something more. In this case, as I was saying, this scenario was prepared to be a short scenario so that we could implement with a high number of students. We gave them over here the more in-depth explanation. Ideally, we would have here an activity that would help them understand where over here they failed. Okay, so the idea of my presentation over here is not going through the details of what we have done, but the concept of how to create the scenario. And then we still have here the reflection, and with different paths, we go a little bit further in the curriculum, because we also talk about the polar star, and that is part of our curriculum. So in the reflection part, we can really explore a little bit more some topics that have to do with the curriculum of our Portuguese physics at this grade. And finally, they go to the end. So as you see, this is like a labyrinth that you can go quicker or you can go slower. Over here, ideally, we should have an activity for those that have been doing very high scores over here that would challenge them a little bit more. For instance, we could have something that was more physical that they could explore over here, or eventually over here we could have them think about the different seasons depending on the regions and the different climates. If you're near the mountains, if you're in the desert, not only with latitude, but also with the geography of the regions. That would be something that would be interesting to explore over here. This is a short scenario. As I said, we needed lots of implementations because we wanted to test the AI part of the project. I'm just going to show you. Okay, this I had already shown you. This was the first tentative of the scenario, but it was much longer and it couldn't be applied, and we wouldn't have been able to apply it to implement with so many students. Over here, this is the Portuguese version, and it has had, I don't know, more than 500 students. And what has been done very recently is the way that the students answered and the paths that came from each implementation, it was analyzed by AI. So I'll just go over here before I'll go to the, this is going to take a little bit while, but I'll go to the other one because I know we don't have that, not this one. The Portuguese one over here. This is the Portuguese one, and I'm going to put up to today, and I'll apply, but this is going to take a little bit too much. So now let me see if I can just put this.
Do you want me to do it in the background while you're doing something else, and then we can share it from my screen later?
If I just choose one to apply, it should be quick. It should be quick. Let me now reset. Okay, I think it's easy like this. It's over here. Oh, I've reset it too much, I think. No. So let me go back here. And over here, if I just put some 24 December, no, October 24 to 25, let's say March. I think didn't have that many implementations, and it will show over here how the students performed. This is anonymous. Those that have been at the other webinars, they know that this is anonymous. I'll come back to show what it has over here, just to make sure that you understand that it's from this data that comes from here that it was possible to do the scenario metrics and AI. This is something I still haven't been able to see in detail because it's quite recent. But this means that after having a big number of implementations, this goes through an AI program that will show how the students performed by category. It will show activities that it thinks don't work, and it will give us lots of proposals. And now I can look at what it's proposing, and I can redo or readapt my scenario based on the implementations. As I said, this is not a perfect scenario. It never was. While we were implementing, we were already seeing that many things could be changed, but we didn't want to change because we needed the AI to have the whole implementation with a big number so that it would give us the feedback. So since there are different paths that the students can take, in the end, there is this possibility that AI can go through and give us suggestions on how to improve our scenario. It's not showing, but it's not very important. This is more important. This is where I wanted to come to in the end, is that after understanding how we create our scenario, we can implement it, and then we can have a feedback of how the students did through the different paths that they showed. And I'm thinking it's exactly 1 minute to 1 hour. So I'll stop here. And if there are any questions, please, I don't know, any comments, any suggestions? I don't know if this was what you were expecting or not. I didn't want to present the actual scenario because it's very specific. It's only interesting if you're going to teach the seasons. But I think it's a good example that can help you think about what has to be in your mind when you try to create your own scenario or adapt an existing one. It's very good if you have already an activity where you know where the students, many students don't really understand, others do. Like this, you can have them go through different paths. And I think that's one of the biggest strengths of the DSpace, besides collecting in the back office all that data that shows how the students are doing. And I'm going to shut up. But please, if you have more questions, we're here.
And just to mention while we're waiting for some questions, I'll put a couple of links in the chat too. So if you haven't yet signed up for next week's webinar, well, the focus will be copying and modifying or tailoring learning scenario to your own classroom needs. That's the one for that one. And I'll also put the link to the webinar schedule for the remaining webinars. And it's also now finally, sorry about the delay with it, but it's finally got the recordings from the previous 3 webinars that are all up there as well. And it, of course, from this one, then it'll be on there soon. And now that the workflow is more streamlined, it should be relatively short to get it on after this.
Any suggestions for different kinds of webinars? I would have liked to have had more questions, but this wasn't still that supposed to be that interactive. But we would love that in the next webinars you are really interactive with us, because we want you to be doing things and asking us and showing us what you're doing. So, José, Claude.
Excellent.
Of course. So it's already there. But you're making a copy without the AI review.
Don't worry, I will find out how to use it.
And then I have a question for the participants. So I guess maybe if you can find the reaction button to like give a thumbs up or give a heart, or I don't know if you can easily find like a thumbs down. But let us know if it would be useful to also have some kind of discussion group where you could contact us and contact each other between webinars as you're working through some of the things, developing scenarios. Because that's something we've been discussing at EPS. And part of it is if there's actually an interest, like if you guys would be interested in joining such a group. Because if it's something where we have like one person joining, just email me. But if there's going to be multiple people, okay, we're seeing a number of thumbs up. Well, at least 4, which is great to see. Oh, and then a whole explosion of thumbs up. So, okay, so that's very useful feedback for us, because if it's the kind of thing where no one actually joins, it's not worth doing. But if people are interested, then that's something that would be good to be in touch with you. People who individually email, it's always great to hear from you. And like even today, there were two of you who, one was just an issue with the access code. Like it's always good to be able to help out, but it turned out it was a typo I'd put in my email to the access code. And if people had seen that chain of messages, then it would have clarified for more people too. So even simple things like that, there's some advantages of that. So thanks for that feedback on that. That's useful to know from you guys. Are there other things we want to ask them before we let them go?
I would like to know if more teachers are from physics, chemistry, science, biology, because next webinar we're going to adapt a scenario. So we would try to choose a scenario that has more people interested on.
And I guess that's something I could have also relayed to you from the form, but from the sign up form,
Oh, okay.
I can already tell you that of those who signed up, which is not the same subset as who are here in the webinar, but 39 self-identified as teaching physics. The nearest other was chemistry with 17, earth science, oh no, earth sciences with 18, biology with 14, general science with 16. But again, that's not necessarily the subset of who's here, because we had 70 something low signups and there's about 20 people who are here. So definitely from the chat, that's useful that everyone mentioned physics is at least one of the things they teach. And then the most common others are geography and astronomy, which is different than France. And I don't know for sure. I think Portugal. I'm not sure.
Astronomy is
Geography
inside
and astronomy
physics.
are taught with earth and life sciences. So it's biology with earth sciences, and then physics and chemistry are grouped together.
We have physics and chemistry together. Astronomy is inside physics. They talk a little bit in sciences, but not. I don't think I even think they took it.
We have science, the 5th and 6th grade science in general, and they split in the lower secondary level, and after that we have the biology and geology in the secondary upper level, and physics and chemistry. In the 12th grade, so it's the last year before the university, we have physics, chemistry, biology, and geology separated, but the students have to choose between two of them.
And so I think we can say an overwhelming majority of those who responded in the chat at least teach physics. Often it's physics and something else, but physics is a very strong common thread. Which is probably biased that the invitation came out with the European Physical Society.
Of course.
And so any last things we want to say, or?
I think we can let them go.
Perfect.
For some of them, it's already 8. For us, it's 6. For you, it's 7. It was wonderful to have you all here. Really a pleasure to be here with you.
Yes, it's been great. Thank you for joining us, and we hope to see you again next week.
Ready to adapt a new scenario.
Have a good evening,
Bye.
everyone.
Have a good evening.